students, good morning. Today we'll learn about the non-aqueous solvent. So it is the third chapter under paper 1 inorganic section. Okay, so under which you have to study solvent properties, reactions in liquid ammonia and reactions in liquid sulfur dioxide, and which is of 3 hours portion. Okay, so basically there is a relation you are well familiar. When solute mixed with solvent gives the solution. Solute may be solid state, or it may be in a liquid state, or it may be gaseous state. Similarly, solvent may be in solid state, liquid state, or gaseous state. And if both of them are in the same state, the one which is in larger amount, okay, referred as solvent, and the other one referred as a solute, which is in smaller amount. Okay, so with this, we'll move on to the properties of solvent. Say the water. You are well familiar. Water is an excellent universal solvent. Why it is taken as a universal solvent? So everyone knows it has very good properties with which the mankind will live very peacefully. Is it? Say the water is having, say, odorless. It is neutral in nature, non-toxic, non-poisonous, isn't it? Safe handling, so cost-free, it's abundant, isn't it? And it dissolves most of the compounds, and also it has very high dielectric constant and very high liquid temperature range or liquid range temperature. It has very high liquid range temperature. Okay, with all this, say the water is taken as universal solvent. So water which dissolves maximum number of salts, and over that it is a non-toxic, non-poisonous, and which has high dielectric constant. Okay, so less viscous, and it is abundant in nature, and it is safe handling because it has no odor or any, say, dangerous or hazardous effect on human beings. So with all these properties, the water is considered as a universal solvent, or it is an excellent solvent. Okay, so in any solvent, it should be, its behavior depends on its physical properties as well as chemical properties. Okay, see the properties like melting point and boiling point, they are very important in order to know in what temperature range they exist in the form of liquid. For example, water, 0 degree is the melting point of the water and 100 degree is the boiling temperature of the water. That means below 0 degree it is in solid state, above 100 degree it is in gaseous state. So in between 0 to 100, such a long range of temperature of water, it exists in the form of, say, liquid state. It exists in the form of liquid state. Therefore, this is said to be a liquid range temperature. So in case of ammonia, if you look at the ammonia, melting point of ammonia is minus 77.7 degree centigrade, and the boiling point is minus 33.5 degree Celsius. So compared to water, the temperature is very low, below 0, and the temperature range is also less, isn't it? Only 40 degree difference, or 44 degrees difference is there. So in case of liquid sulfur dioxide, say the melting point is minus 75.5 degree and the boiling point is minus 10 degrees centigrade. Even this is also at very low temperature. It has its liquid range temperature. So the water is having very high, so dielectric constant says 78.5. So dielectric constant is nothing but, as you know, the force of attraction, that is electrostatic force of attraction, is given by the relation Q1 into Q2 divided Q plus into Q minus divided by dr square, where F is force of attraction between the solvent molecules. Say Q plus is the positive charge on the ion, positive ion, and this is Q minus is the negative charge on the negative ion. D is the dielectric constant, and R is the distance between the ions. Okay, so now say if D is high, so if D is high, dielectric constant is high, then the force of attraction between the oppositely charged solvent ions, ions of solvent, is less. So when the dielectric constant is more, it is easy to, or it is a force which separates or which keeps the ions of solvent away from one another. So that is the dielectric constant. So force of attraction and dielectric constant which are inversely related. Okay, say force of attraction is greater means dielectric constant is less, and if dielectric constant is greater, the force of attraction is less. So if the dielectric constant of any solvent is high, means the ionization or the ionic reactions are easy to conduct in those solvents. Say dielectric constant of water is 78.5 at 0 degree, ammonia is 22 degree, and HF, hydrogen fluoride, is liquid hydrogen fluoride is 83.6 at 0 degree. So even dielectric constant is also plays an important role. So viscosity, if the liquids are very viscous, filtration or precipitation, so etc. will be difficult in those solvents. Therefore, lesser the viscosity, greater will be its, say, use as a solvent. Then heat of fusion and heat of vaporization. So the knowledge about this of any solvent, it is indicates the force of attraction existing between the molecules, isn't it, or bond strength. So heat of fusion or heat of vaporization, they are related to, or which indicates the strength of bond existing between the atoms or molecules of that solvent. Say they are also very important. And the solubility, say water dissolves large number of salts or compounds, and even then there are exceptions. Few of them are, say, insoluble, or they are partially soluble or sparingly soluble. Okay, so these are all the, say, the certain properties of water, and with all these properties the water is taken as a universal solvent. Now with this we'll move on to the, say, classification of solvents. Say solvents can be classified based on different criteria. See the first one, protic and aprotic solvents. Protic or protonic, aprotic or aprotonic solvents. So these are the solvents which produces protons when they undergo ionization, or when they react with the others, if they are producing protons, they are said to be protonic. Or the solvents which contains proton or hydrogen in them, they are said to be protonic. And those which are not containing hydrogen in them, that means they are sort of which cannot be produced. Okay, even benzene is having C6H6, but it doesn't undergo ionization, isn't it? Or we can leave it, say, liquid SO2, liquid, say, POCl3. So these are the certain liquids which are taken as examples under aprotic solvents. Carbon tetrachloride, POCl3, phosphorus oxytrichloride, sulfur dioxide, liquid sulfur dioxide, see, dinitrogen tetroxide, tetraoxide, etc. These are the example for aprotic solvents. Now the second one is, say, acidic, basic and amphoteric solvents. You are well familiar. So acids are the one which produces H plus ions, and bases are the one which produces OH minus ions in solution. And amphoteric, based on the conditions, the water may act as an acid or as a base. So it is, therefore water is a amphoteric in nature because they are weakly either acidic or basic. Similarly, ethanol, C2H5OH, methanol, methyl alcohol. So they are the example for amphoteric solvents. Okay. Ionizing and non-ionizing solvents. The name itself indicates the solvents which undergoes ionization They are said to be ionizing solvents. So for example, H2O, when it undergoes ionization, it produces H plus and OH minus. But H plus is very active. It suddenly reacts with one more molecule of water and thereby it forms H3O plus, that is hydrosonium ion. In any case, if there is a H plus liberation, it reacts with one more molecule of solvent and exists in the form of, say, the positive ion. Okay. Say ionizing solvents which undergoes ionization. So okay, even in ammonia, see even here also there is a liberation of H plus ion, therefore 2 moles of NH3 gives NH4 plus plus NH2 minus. So this is an ammonium ion, this is a amide ion. See the liquids which undergo ionization, say in case of SO2 gives SO plus, SO3, so SO2 plus, SO3 minus. So these are the, say, ions which produce sulfo, thiosulfonyl ion, sulfite ion. So okay, say these are acidic in nature, these are the basic in nature. Even here also this is acidic in character and this ion is basic in character. So now ionizing and non-ionizing solvents. Say ionizing solvents are H2O, NH3, SO2, etc. Non-ionizing solvents, we can give the same example, say carbon tetrachloride, or say benzene C6H6, or toluene, so ether, etc. Okay, which do not undergo ionization and they are said to be non-ionizing solvents. So with this we'll move on to the next one, liquid ammonia as a solvent. Okay, we'll discuss in the next class. Thank you.